Okay, so we are live now. So welcome everyone to this MLOps course, the class one on Dockers. So I hope you guys are doing well. Now, first of all, before I begin, let me just explain you that what we are going to discuss in this particular course or this particular in today's session and what is in general MLOps, right? And then I will discuss what do we have for this particular session. As a like Docker, a lot of you, I think I put a poll. I think none of you have actually worked upon it, so it's fine. It's a great opportunity to learn. So first of all, let us study what is this going to what is this course is going to be let me just okay. So yeah. Now, this course is about MLOps. This is a totally free course which we are organizing, right? MLOps means stands for machine learning operations, but it is not explicitly related to or constrained to machine learning. People who are into development field, for example, data engineering, people who are into machine learning engineering, people who are into AI engineering, or any kind of development process, people even who are product managers, who are let's say working in any technical role, they should know this, at least the concept. They should know that, because docker or MLOps is something very important. I will tell you what is the importance of it before we begin anything, right? So this will be a series of live sessions which I'll try to conduct one session every week or every alternate week, but let's see how things go. But main thing is that if I'm keeping it for free, there everything comes at a cost. That I'll be sharing some assignments. I'll be sharing some tasks that you need to do after every session. Maybe you will be given a week or 2 week to submit that, right? And if I don't see submissions by that duration, then we will not continue. So it's totally up to you guys. Like today there are 32 people. It's very good. I want same enthusiasm as we move ahead as well. I'm not scaring anyone. I'm just telling that uh, this is an important part. At least theoretically you should know, right? And for this you don't need to have any like people who think, oh, I don't know machine learning, let's say I don't know data engineering. It's totally fine. This is totally separate field from all that. Okay, so we will have around at least 10 to 12 sessions on this, right? I'll cover all the major concepts which are there, major tools which are used in MLOps or LLM ops or data engineering development. So we'll go through them one by one. Today we are starting with Docker, but we will take up all the tools which come into play. Okay, so are you good to begin? Anyone any doubt before we start? These sessions will be available on YouTube for live, but try to attempt in real time. It gives a better exposure, but again, it's your call. Okay. So before just repeating, yeah, please.
I have a doubt.
Yeah.
So, same error that was coming for you, like some.
Just save the file. So what you need to do, just save the file. Actually, just save the file and add these two lines at the top. These two things. Okay.
Which two things?
I'm just pasting it. Okay, but even if it's not running, it's fine. Just try to focus on the session, right? uh,
Okay.
then you can do, I mean, this core, all that you have done, right? We have done the AI sessions, we have done all this, right? So I've just taken, suppose you have, let's say you have any machine learning model, any data engineering project, anything. So for now, for this session, we have this AI chatbot with which you can ask anything. Okay, and it will reply. For example, what is let's say what is capital of France, right? So it will reply anything. Our goal is not to understand how to build this chatbot. Our goal is to understand how to take this to deployment. Okay. So all good. Anyone, any other doubt?
Just a quick one from my side. Sadhu, am I audible?
Yes, you're audible.
Okay, just a quick one. Hopefully, you find this. My only question is like a person who doesn't hold any coding background, how this is going to be?
It,
Am I will be at the same pace as you want me to be?
if you don't have coding background, that is also totally fine, right? There will be
Because
some
I'm a
code
part
which
of
I will
sales
show.
and tech. Mhm.
Sorry.
Because I'm a part of pre-sales domain, so I haven't done any coding before, or not even in my college
That's
days.
totally fine. That's totally fine, right? Uh, just a second. Uh, Yeah. So even if you are or like you're not from coding, or you have never coded any ML model, or let's say uh, it's totally fine. uh, you just
Never.
need to know there is a thing called model, how we take it from development to production, right? That is what we are going to study. If you don't have coding background, that's totally fine, because MLOps is more of conceptual. um, of course there is some coding will come, but that's not mandatory. If you know the concept, let's say if you are a product manager, if you are a lead in your company, right, even if you're a junior person, right, you will see people talking about these things, that okay, let's take it to development, let's take it to production, let's do load balancing, let's do the API calls, right? So there will be
Mhm.
those terms you will constantly hear. Now you need to know what are these exactly, so that you can be part of those conversations, right? So that is why
Perfect.
we are having
And
this.
what would be the takeaway of this calls once it is have to turn into 12 classes? What you said. What would the takeaway? What would be the how should I expect for myself? How it is going to be helpful in that in which domain?
It will help you in
What
this
we
way that, see, I will explain that part. I will explain. I'm coming to that. That
okay,
what is
that's
ML,
okay.
right? I'm coming to that part. Yeah.
Sure, sure.
Anyone, any other doubt before we begin? Okay, this is not a Python class. This is nothing. I'm just using a Python code, but this is not a Python class or anything, right? We are simply going to focus on development. So let us start studying this particular part. First, let us study what is MLOps, because that is something important. Uh, let's say, can someone tell me what do they infer from, what is the meaning of MLOps? If someone can tell me, or DevOps in general, not only ML. And MLOps is just a fancy name given. Technically, it's DevOps.
Can
So
I?
yeah, please.
I've recently studied about DevOps, and what I understood from this is this that actually when we write the code, then that part is development, and then the second part is about the deployment.
Yes.
So this continuous integration and this continuous deployment, earlier what was happening, code was written and then they were
Yes.
deployed, but
Yes.
now the things are changing. Like whatever we are writing, we want to see that what is the output, so that it can continuously be improved. So this complete cycle where continuous this thing code writing part and its deployment part, this continuous cycle is DevOps. And through this, what happens that whatever is the output, we can check and we can have the option to correct it so that
Yes.
it can work optimally. This is what I understood.
Yeah,
Thank you.
that's right. That's right. So it's kind of right. Just I'll add couple of more things. So so like you all guys are, as far as I know, you go all guys are from data background, or maybe something around that only, right? Now, you or some of you would have studied uh, Power BI, SQL. Some would have studied, let's say, data engineering, that data ingestion, doing Azure, doing cloud services, doing warehousing. Some would have studied machine learning, AI, building this model, that model. Okay, uh, this all part is good. Okay, it's fine. But think like this. For example, let us say we all use internet nowadays. There are a lot of websites. For example, let's say I take example of my website only, right? If I go to this website, practice.datasensei.com. Now this website is so you can practice SQL questions, you can do a lot of things here, right? This website is in live mode right now. Okay, anyone across globe, if we just write down like put this link, he or she will be able to access and like code on this website or whatever he or she wants to do, right? Yeah. Now think this way. So does not matter. So remember, every model, every project that you do, whether it is data engineering, machine learning, or something else, has some code in the backend which is running, right? Now, but for example, that is running on your system. For example, this chatbot that I developed right now, if I share this link with you, will this link work on your systems? Tell me.
No,
No, it will not work.
It will not
No,
work,
it's not.
right?
it will not.
Okay, let's say I convert this into a proper link that which is accessible to everyone. It might work initially, but the moment I close my laptop, because this code is running on my laptop, right? The moment I close my laptop, this link will stop working. Agreed?
Yeah.
Right? So what happens is that then and let's say I launch this saying, okay, this is my chatbot I have launched for everyone, right? This will be totally unreliable, because the moment I close laptop, people will not be able to access it, right? So this is the first problem, that okay, we study building machine learning, doing data engineering, we do a lot of things, but uh, how people can access that, right, in real time and without any break, without any interruption, how can people access those things, right? So this is the first use case of, there comes the deployment part, that okay, the first part is I have built something, right? But how I make it accessible to everyone 24/7? This is the first part. Accessible 24/7. How can I make this? It could be a, uh, it could be, for example, any link, any website, that whatever you see. Now the second part, that the problem that we also face is that, like, lot of time what happens, there are constant upgrades to websites. For example, I talk about this website only. This website has been built over multiple phases, right? Initially these things were not there, we just built a small thing, but website was always live. For example, let's say even you go to ChatGPT, let's take an example of ChatGPT. You go, this website is always running, uh, right? They might be doing some changes, they constantly do some changes, right? Sometimes there are bugs, code is not perfect, they bring more additions to website, more features. But has it ever happened that the website ChatGPT stops working for you? No, it always keeps on working. You automatically see some upgrade. For example, in your phone, let's say your phone keeps on upgrading, right? You see a message that okay, there is an upgrade for your phone tomorrow at 8 p.m., something like that, and automatically everything happens. Does your phone stop in that duration? Like, does it interrupt your experience of using a phone? Yes or no?
No.
No, it does not interrupt, right? So this part is called continuous integration, continuous deployment. This is CI. This is called a CI/CD pipeline. Like a lot of you would have heard, lot of you would not have heard. So what does continuous integration and continuous deployment means? That let's say there is an application which is running online. Okay. Now this is the version 1 of it. This is the version 1. Now in the backend, developers are working, they are improving it, adding things, right? And let's say version 2 comes in. They have decided to launch a version 2. Will they close the version 1? No, they never close the version 1. What happens that in the backend, as you are using, they update the system, right? And the moment system is updated, v1 is swapped with v2 without you getting to know. Like, it does not hamper with your experience. So integration means, what is v2? V2 will be a new code basically, right? In the version 1 you will have a code 1, in the version 2 you will have a code 2, where you have made some changes, upgrades to your codes, and you have pushed to this. So this is called continuous integration, means you continuously keep on integrating your codes, updating them, right? And what is the continuous deployment? It means your website is always running. It does not impact, it does not hamper the user experience. It could be website, application, as I mentioned, right? So this is called continuous integration and continuous deployment. Anyone, any doubt on this part, this definition of CI/CD?
I just have one doubt here, that for this entire process, uh, uh, does all the codes are put in the GitHub and then they are deployed and then they are taken back? Means what is the total cycle? That can you slightly elaborate?
I will explain that. We'll come to that one by one. Don't worry. We'll come to
Okay.
that. That is called the machine learning, the whole data cycle. We will discuss them. But tell me, is this part clear to everyone? What is CI/CD? Like, you will hear this word, I think, almost everywhere. CI/CD. Even if you're not a developer, you will hear this word. So continuous integration. So any project that you're working, it should have there's a proper CI/CD pipeline for that. Okay. So there are people which you see, there are people who are analysts in a company, right? There are people who are data scientists, for example. There are people who are data engineers, and then there are people who work on MLOps. They are also engineers only, maybe something like that, but their work is different. Their work is not to build models. They will take the models built by scientists, machine learning engineers, or some analyst, or something, or maybe they will take from data engineers. Their work is to take that thing that you have. So basically what you have created is a you can say a temporary version, a project. You have just created a project. They have to make this project live for everyone, right? This is the part which is called MLOps, DevOps, or anything. Okay, all set, guys?
All good.
Good, right? Now, for this whole cycle, as I mentioned, there are three major steps. If you see, one is data ingestion. Here mainly data like this data engineers work, right? They source the data from raw sources. It could be a live streaming data from Kafka. It could be a batch processing data from anywhere. They will just ingest it, right? This process has to be automated, because what happens tell me, is CI/CD required in the data ingestion part?
I think it is required during the coding part.
No, but how is it required? Tell me. Let's discuss that. How
Means
CI?
once the data is ingested, it is, it is whatever task is required, we code for that, and then we deploy that.
Forget the coding part. Let's talk logically, right? What happens? Suppose you have a store. Let's say this is a store from where data is coming. Okay, or let's say this is your online website from data is coming, and let's say this is getting stored in your cloud server. For example, let's say this is a cloud server, which is, we can say, AWS, for example, or it could be your local, anywhere you're storing your data. The data flow never stops, right? The data always keeps on coming, right? You define a format that, okay, from this particular thing I need a data in this particular format, and as the data keeps on updating or new data keeps on coming every day, it keeps on pushing here in AWS, right? We as analysts see things from here, but this part is also called CI/CD, because they have set up data in the raw data storage part and the AWS part such a way that the moment there is a new data in the system, it automatically passes through the pipeline and people are able to access it, right? People who are working in company, you can easily access any table. Every day table gets updated. But how does that happen in the backend? In the backend, there is a CI/CD pipeline. Okay, clear, guys? So it happens for data as well. It happens for machine learning as well. Like, for example, people who create machine learning models. Okay, you have created a machine learning model, but you have to take it to a deployment level so that people can start using it. For example, let us say you have created a machine learning model of a fraud detection, that, okay, whatever credit card transactions are coming, there is a model that will take credit card transactions in real time. Okay, and it will detect if a transaction is fraud or it is not fraud, right? This needs to happen in real time, correct? Otherwise, the transaction will happen, the company will go under loss. So this is the CI/CD for machine learning part. So this is generally people call it MLOps. Okay, and people for it is called data engineering as well. It is also called DevOps part for data engineering. Then nowadays people have started using instead of machine learning, like we also use AI models, right? So people call it AI ops. I mean, these are just fancy names given. Eventually everything is DevOps. DevOps, it could be for data, it could be for machine learning, it could be for your AI thing, right? Your AI part. Okay, so is this clear? What is the meaning of DevOps? What is the meaning of CI/CD pipeline? What's the role of data scientist in MLOps? The data scientist, they do not explicitly take part in MLOps, right? The role of data scientist is just to create models, to test the models, to see if everything is working or not. Like the logic, you have to follow the logic, because uh, see, MLOps people will just deploy it, but the logic behind that, for example, the chatbot that is created here, how this chatbot is created, this will be done by a machine learning engineer or a data scientist or someone else, right? MLOps person will be able to will deploy this. Now what will happen, that once people start deploying, they will start seeing that your code is inefficient. For example, as a data scientist, suppose you created a code that I created a machine learning model, I created a some kind of model, right? But the code is inefficient. It is taking a lot of time. It is running very slow. So DevOps people will tell you, or MLOps people will tell you that, hey, your code is not efficient. You need to improve your code, right? And then as a data scientist, you need to go back, look at your code, how you can optimize your code. So they work in parallel, I will say. Okay. Is it clear? Yeah. So all these roles are integrated in a company. You will see there will be machine learning engineer, there will be data engineer, there will be scientist, there will be a DevOps person. All will work like parallelly. So these things keep on going parallelly. Like those who have worked for production teams, they will see that. Okay. So this is the definition that we discussed so far. Is everyone clear? Before I move forward, I will discuss the flow, what all things are there in MLOps. Okay. So in this course, so let's start discuss what we are going to discuss in this particular course. Now there are certain concepts which we talk from the development point of view. Is first of all, let's is called Docker, that we are going to discuss. Okay, which we are going to start in today's session. After Docker, we will be discussing about fast API. That what is a fast API, how to convert your models into API. Third thing, what you need to understand is very, very important principle. It is called Kubernetes. Okay. Fourth, we will do basic GitHub. That you all see that, okay, you go and publish your repositories in GitHub, but how to do through code. Okay. That is also very, very important. Then you will do GitHub actions. Okay. GitHub actions. That this is what we are going to do. After that, we are going to do a little bit of cloud. We will study how to deploy on cloud. For example, AWS, Azure, and GCP. I will try to take up example of all three, right? One project on all three. So this is the major pipeline. What you need to do. Apart from this, there are a lot of other things as well that come in MLOps. For example, there is MLflow. Okay, it helps you in orchestrating. By orchestrating, I mean to say managing the workflow. Just think like this. Okay. Then there is a DVC tool, which is called data version control. Okay. We'll be studying this, and there are a couple of 3-4 more tools. Like, but the overall objective of these tools is that you have to take something from a normal project in your laptop to an actual thing which can be deployed on a website. Okay. All clear?
I just want to ask one question, Satvik.
Yes.
So whatever you suggested right now, this is what is all about the, the software cycle means which takes place means on the one side we are producing the model and on the other part we are deploying it.
Yes. Yes.
This is what the total pipeline is.
Yes, this is what the, so let me tell you the pipeline, how the pipeline works, right? So if you have to understand the whole pipeline, it goes like this. So first of all, what you do is that suppose you take the data part, right? So like for example, this is your data ingestion part. It comes from somewhere. So here you use to orchestrate this, we mainly use DVC, we use Apache Airflow, right? We use MLflow or Airflow, whatever you want to use. MLflow is there, Airflow is also there. There are a lot of things. Once you're done with this, there are more tools, Prometheus, like I can keep on going, but major things I'm going to discuss. What happens after this is you create your model, as we showed, right? Create your model. This is I'm discussing about the pipeline. Create your model, whatever machine learning model you're building or a data science project you're building, anything you can do. First of all, you deploy it in a, you basically containerize it. This containerization process is called Dockerization. I'll explain this today. After Docker, what you do is you put things, no, first of all, you convert into fast API, actually, not Docker. You convert into fast API, then you do Docker. After Docker, what you do, you take things in, so fast API, Docker, then you will do Kubernetes. Okay, Kubernetes. Once you are done with Kubernetes, your application is well running on the website. So what you do, first of all, you take any Python code. Remember, this is a Python code or whatever, let's say Java code, Python code, whatever you have created here. You, you, when you launch things online, for example, they go in form of API. I will discuss what is API, how they're connected in the fast API class. But for now, understand that softwares interact in form of APIs. So they will not interact in form of your, let's say, this code, that okay, this code runs its output. The output of any code should come and go in form of API. Then only softwares can take it. So we develop fast API for that. After that, we do the Docker part. Then we do the Kubernetes. Once you're done with Kubernetes, your product is ready, available on the website. Now what happens that there will be constant changes, right? Let's say I launched a version 1 of my website today. I have to launch a version 2 of my website 10 days later. So this is called version control, that version 1, version 2. This is done through GitHub. Okay, so this part of version controlling is done through GitHub. Version control. There are a lot of methods, but like I will use GitHub, but you can explore. There are multiple methods. Okay, so GitHub, what it does, have you guys read about branches? Like you would have seen this, right? There is main branch. There are, like, you can keep on adding branches and tags. So this all comes under GitHub. Once you're done with this, you will study about GitHub Actions. So this is also part of version control, but it is for more better deployment. It is called GitHub Actions. Okay, so these are the major steps. If I have to talk about, this is the pipeline. Your data will come from here. You'll create your model, then you'll convert it into an API, then you will Dockerize it, then you'll use Kubernetes for load balancing, then you will create version control using. Right now, you will not understand what I'm speaking. It's totally fine. I'm just telling you the pipeline, that how we are going to proceed. Okay, is it clear, guys? I mean, there are more steps in between tools, but major steps remain these only. That I will add Apache Airflow, MLflow, more things here, but overall things will remain these only. Like we will study about deployment in cloud, right? Once you do this, we will study how to deploy these things on cloud servers. That is also very, very important. Okay. So all good, guys. What the difference between fast API is a kind of API only. So that I will cover in fast API class. All good. I mean, don't get overwhelmed by seeing all this. If you're seeing for the first time, it's totally fine. These all are very conceptual things. Coding part you have done here. After this, everything which we are going to study is more of conceptual. Like Kubernetes is totally conceptual. Docker is conceptual. If you see, there's not enough coding in Docker. There's technically no coding in Docker. There are just few commands you need to know, right? And version control also doesn't like have enough coding. So these all things are conceptual things. So that's why I say, even if you don't have which image you are asking, this one that I'm creating, I will share after the class. Okay. So as I mentioned, all you need to care right now that, okay, let's build this mindset that we have a machine learning model or AI model that we have created. Okay. And we have to learn how to deploy it. Okay. The backend part, let's say a data scientist has done or someone else has done, we have to learn how to deploy it. Okay. So that's it. Now we will begin the Docker part. This is just a basic introduction to what is MLOps in general. We will go into each of these topics in detail in different sessions. Today we are covering Docker, and we will keep on covering them. Okay. All good, guys. Anyone, any doubt? You
No,
don't,
sir.
yeah, you don't need to have a coding background for this. So that's why I'm saying, that's why I said everyone, please join it. At least understand the concept that I'm going to teach. Okay. So let's start with the Docker. Uh, who all of you have studied Docker ever in life or have heard? I mean, I know I put a poll, but a lot of people answered that they haven't. But Have you guys ever heard of Docker? What is Docker? How does it work? Anyone? Okay. Okay. It's fine. If you have not, it's totally fine. Don't worry. I'll explain that. So this is Docker. If you see, this is the website docker.com. Um, First of all, please do one thing. I already told that download it, the Docker desktop. If you download a Docker, it will look something like this for you. Okay. I will explain what all these things are in the session, but please just download them. Okay. First of all, let us try to understand what is the meaning of Docker and all that. So it says develop faster, run anywhere. Docker is the number one tool which is used in every company. It's not that it is just like few companies use AWS, few companies use Azure, few companies use GCP, but every company use Docker. Okay, so that's why Docker concept is must for everyone. I mean, there is no uh, there's no option. You have to know if you are into the development, if you are into the ML cycle or whatever. Okay, so let me here is okay. Let's discuss a scenario first of all before we begin understanding Docker. Suppose let's take an example of McDonald's. Okay, take an example of McDonald's, or let's take example of Pizza Hut or Domino's, whatever you feel better. What is why these? Can someone tell me why these brands are so popular, right? That everyone wants to have it. What is that USP of these brands? Can someone tell me what is it? Yep.
Anytime, anywhere.
Okay. Someone said anytime, anytime, anywhere. Okay.
Because of taste.
Great. Okay, that is also fine. Yeah. Anything else? Okay.
Brand.
Someone mentioned rate. Someone mentioned brand. Okay. What else? There is one more thing which you guys are missing.
It will always be the same anywhere. You'll have
Exactly.
it most
Exactly.
likely.
Same. The main concept is that why we go see rate, though you will get cheap things here and there as well, right? Anytime, anywhere is also fine. Even if McDonald's does not always work 24/7, right? It closes. But the main thing why we go McDonald's or Domino's is that taste is same, right? Is same everywhere. Does not matter if you are eating uh, a McDonald's from a restaurant in Delhi than something in Bombay. Of course, let's say if they introduce some new kind of burgers, they are separate. But let's say I take a simple example of McAloo tikki, right? The taste remains same, right? If you take a basic cheese pizza of Domino's, it will remain same wherever you go in India. Across countries, it will vary because people's taste across country changes, but in a country or in a region, it will remain same. Even in your city, if there are 5 different stores of McDonald's, does not matter from where you take, things will remain, taste will remain same, right? And that's why it makes these brands like more trustworthy. People trust them a lot, right? And like these are just like go-to brands for people while eating. Same thing we need to understand here. So for example, uh, let's look at this concept. We created this AI application here, right? I created a chatbot which is working fine on my system. What is the guarantee that it will work fine on your system? What is the guarantee it will work as it on someone else's system? Tell me, is there any guarantee for this? And what things influence this? What things actually influence a particular model's running or result? What things, tell me, actually influence?
The configuration or the environment in different setup might be different, which might impact the functionality or the way it functions.
Yes. So for
The
example,
prerequisite
let's
to
say,
make it run,
yeah, please say.
the prerequisite which is required to make it run on any platform or any
Exactly.
system, I would
See,
say.
the code will remain same. I will share the same code. It will run. Code will remain same. Code we are not changing, right? Even if code remains same, things will be different. So what I mean to say, for example, presently this is running on my system. Okay, my system has a certain RAM. Okay, it has certain version of, for example, this application is a Python application. There can be any application. It could be a Java application, it could be a Node.js application, it could be anything you can think of, which are available. Right now I'm just using a Python application. Now what things influence this is, first of all, the RAM of my system, right? The response that I'm getting here, it depends upon how I have coded. Second thing, how good my RAM is, because suppose if I'm training some model on my personal laptop, it might take some time. But if I'm training some model on a big cloud server, it might take less time, right? So first of all, RAM plays a role. Agreed, everyone? Yes or no? The response time for which you see can vary system to system. Let's say I developed an application saying that, okay, I built a chatbot, I built a very good machine learning model. It instantly replies you everything, something happens. But the moment you start using it, it takes a lot of time. What is the difference? I might be working on a RAM of 200 GB and you could be working on a RAM of 10 GB, right? There's a difference between systems. Yes or no?
Yeah.
Right. So this, we don't want to let, so what happens that we don't want these, so technically, the output of my model or how my machine learning model is working, it totally depends upon on what system I'm running, which is a wrong thing. ChatGPT does not matter whoever uses, you get the same response, you get in the same time. So first of all, this is RAM plays a bigger configuration. Second thing, it plays the versions. For example, to run this Python code, I'm using below libraries. If you see, like for any machine learning, sometimes you use scikit-learn, you use something else. I'm using these libraries. Okay, LangChain, Fast API, and all that I'm using. Now, the versions of these things, I'm also using Python, by the way. It's by default installed in my system. So if let's say I do a quick check that Python version, let's say I do this thing. My system has Python version 3.3, 3.1, 3.1. Your system could have something different. I just downloaded this Python today only. That's why it's updated. You might be using 3.12, 3.11, right? Someone else will be. You do not know what Python version your customers are having. So these are called dependencies. The libraries which are present there, these are called dependencies. Now, these can vary person to person or system to system. This will also impact running of your application. Is it right? Even if you create virtual environment, let's say people say that, okay, I'll create a virtual environment. What will happen in virtual environment is that, okay, virtual environment is created, but suppose in virtual environment you mentioned Python 3.13. I created something and I mentioned this as Python 3.13. But the moment I take this application on some other system, let's say I take to my friend system, my friend system only contains Python 3.10. So this application, even if virtual environment has Python 3.13, it will not work in my friend system. Agreed? Even if he is using virtual environment. So this is the difference. This is also a drawback. A drawback you can say, or a hurdle, when we have to take things into production or something else. So how do we handle all this? How do we handle these things separately? How can we handle? There are two methods to handle this. You might have heard in your daily life. The first method which you use in a lot of places, have you heard of this word VM, virtual machine?
Very much.
Yes.
Everyone, I think everyone works in IT, you guys work on virtual machines only, actually, right? And the second method is Docker. Right. So can someone tell me what is a virtual machine? Like for those who do not know, can someone tell me who knows that what is a virtual machine? How does it work?
It's
Please.
a
Yeah, please.
So basically, it's a server. A virtual server is basically a server, which you can access it from anywhere. It'll have its own IP address. Maybe the location is not. It could be also a part of a data center. It'll have its own RAM configuration, its own a hard disk, a space, a virtual space for
Yes.
storage.
Yes.
And it has this particular configuration which you can access, which is as good as you work on your own local machine, but it's not actually a local machine.
Yeah, exactly. So what happens that you go to your normal computer in office, right? You everyone would have used, right? You log into your computers, and those computers are technically connected from backend. Let's say you're using this in India, right? But there are virtual machines which are, for example, present in US, right? There will be a proper, let's say, CPU stored in a data center or somewhere, some other where, right? You might be working through this, but technically you are working on these, right? And whatever files you store, they go here. So these are called virtual machines. That, okay, you're accessing them through your system, but the RAM utilization is happening here, correct? Yes. Is everyone with me on this? The problem with virtual machine is that they are good, no doubt. The problem is that they are heavy. What do I mean by heavy? I do not mean the weight of their weights. I mean to say that they, for example, let's say you're working on a virtual machine, right? Or let's say there are 3 virtual machines connected with your system. They will utilize the RAM of those virtual machine system, right? For every run that you're using. Even if your system has a, let's say, some version installed, they will not use it. They will utilize these RAMs or these systems directly. So even for a small application, what happens, these system becomes they're not using the central RAM which is available. They are just utilizing uh, the RAM of each of the system, right? So their things become little bit cumbersome as your number of computers, number of machines increase. They are good for tasks, but for example, let's say you're talking about a website which has which can have millions of visitors, right? There, this things this thing becomes little tricky. Instead, we use the concept of Docker. So what we do, let me just explain in very quick steps that what we do in Docker. That suppose you have a code, let's say you have a Python code, or let's say an application which you created, just like a chatbot which we created at the top. We will take this application. Now there are couple of terms in Docker which you will study. One is Docker images. Second is Docker container. Okay, I will explain them in detail what are they exactly. But so what you do, that you convert those, put that application convert that into a Docker image. Okay, and over that image you deploy various for example, let's say deploy containers, container 1, container 2, container 3, container 4, just like these things were there. But what is happening now, all these containers are utilizing the same memory only, this one which is present inside this. Okay, and this makes Docker lightweight. So what is the difference between virtual machine and Docker is that what is image and container, forget for now. Let's just follow the architecture. Here I'm utilizing the RAM and memory of each of the nodes that I'm having, right? Here I'm using the central node just to run all these things. Agreed? Any doubt in this? Or it went above your head?
Satvik, I have a doubt.
Yeah.
So in virtual machine, is there like is there a one virtual machine from which many systems are operating, or like from
No,
the
no,
diagram?
it's not like that. That it's a network of virtual machines.
Okay. So
So
like you have
two
drawn
people might be
three.
working on same, it can happen. There's a network of so it's not like uh, one is connected to many, like it's many connected to one. It's something like that. So
Okay,
yep.
okay. Like exactly in the image, like you have drawn three and it's connected to one. So
Yes.
like that only it happens.
The connection is same. The difference in virtual machine, what you, whenever you see Docker, you will always see lightweight, right? Let me just show you Docker lightweight, right? You'll see that Docker is always a lightweight container. We say that Docker is lightweight. What it does, it changes the concept of, it brings this concept of images, which I will tell you, right? And all these things are connected to those images. So technically they utilize the memory of this image only, right? And these are just running instances. Just like you, yeah. So just like if you have studied Python, there is a class and there is an object, right? You create a class and you create multiple objects from that. This is like this. Okay. So here you're utilizing the memory of one. Here for every task you're utilizing different memory. As your system scales up, your system gets heavier. Here your system does not get heavy. Your system remains same. Okay. But the application is different. Virtual machine can be used for big deployments, like for big use cases, but for things like website, machine learning models, data pipelines, Docker is a better thing. But when you have to deploy like big, like for example, in company there are thousands of employees, right? And they are connected to something. There are a lot of data, like a lot of things are there. Their virtual machine can make sense. But when I'm talking about deployment of a single machine learning model or a single data pipeline, Docker comes into play, and Docker is more logical. But what is Docker, we will study. But the architectural difference is this. Is this clear to you, or it's going a little bit complex?
Hello.
Yes.
Yes, so means the Docker can be used as a RDS, remote desktop server.
Yes.
Okay, so means why means most of the people currently and still using VMware and RDS means they are taking from that.
VMware is virtual machine. I told you virtual machine and Docker are different.
Okay, so means Docker is for that containerizers and that VM is for taking the systems.
Yes. Yes. Virtual machines are built for like universal scaling. That is different. But when you have
Okay,
to
so
deploy,
means we can take the means. Oh,
yes, please tell me. Hello.
hello.
Yeah.
Yes, so means I am saying that we cannot take the means remote system of any of the other user using Docker, no?
No, we cannot take. I'll tell you that. But how does Docker work, right? This is just a concept explanation of, there is, you'll always hear this word images and Dockers, images and container with Docker. Okay. So please mute yourself if you're not speaking. If there are others as well on the call. So now let us start studying about Dockers. That what are they technically? What is the concept of Dockers? What are these images which I'm talking about? Okay. So first of all, please everyone download this Docker, right? Can you guys see this in your system? This Docker file, this Docker desktop. Have you guys created this? Okay. So let's start studying Docker now. The session will not go like it's a. This is not like a lengthy session like 3-4 hours. So don't worry. We are the first part we have done. ML understanding MLOps. What is the need of MLOps? What is the need of Docker? Right. That we have studied. Now we will study what is Docker exactly. So let us say whenever you have any application running, there are few things which are required to run an application. The first thing is your For example, let's talk about this Python application that we have just created. Okay, so what do we have? We have a Python file, and we have a some text file, and we have a, so what all is required to run this particular chatbot on my system? Can you guys tell me what all things are required to run this particular application?
Python.
The first thing required is OS, whether it is Windows or it is, let's say you're using Ubuntu, you're using Linux, you're using Mac, or whatever operating system you're using, you need an operating system. If I don't have an operating system, how will I run it? Agreed, everyone? You cannot go, suppose I put this code on GitHub. Can you go and just run on GitHub this code?
No.
You need to put that code in your computer and then run it, right? So the first thing that you need is your operating system. After the operating system, the second thing you need, because this is a Python application, so what you need Python. Try running this code. If you don't have Python installed in your system, it will not run. Right now, it could be a, for example, if it was a Java file, you need a Java in your system. If it's a Node.js file, you need a Node.js. There are, like, if it's a React file, you need, like, there are so many things possible. If it's an HTML file, you need an HTML thing in your system. Like, everything you need, whatever. So this, for this application, we need a Python in our system. Agreed? Third thing I need is, okay, I have Python installed, I have my OS. Third thing I need is my code, which is used to run this application. Without my code, I cannot run this application. And the fourth part and the last part that is required here is dependencies. What are dependencies? Can someone tell me what are dependencies?
The libraries and
Packages.
the
Yeah,
version.
package the libraries that you are using. For example, we are what LangChain, like this is the LangChain application, right? So we use all this fast API, everything. If I don't have this, I cannot run my application. Correct? So I need all this to run a particular application. So what we do in Docker, we say that, okay, so the concept is that, what did I tell you? That you take your code, you take your application, you convert it into, you put it into images, okay, and then on those images you run multiple containers. So what are these images? Now let's understand that these images, this image are the blueprint of your, what all is required to run your application. Okay, so this image, when I talk about Docker image is the blueprint. Blueprint required to run your application. Okay, so when you install every requirement that is present in your blueprint, that becomes a complete image. Okay, let me just restart this. I don't know why this is happening. So for example, in this particular code, we just discussed that what all things do we need to run this application. We need an operating system, we need a Python code, we need a Python installed in my system, we need my code which I'm using, and then I need my dependencies, right? Four things I require. So what we do, that we create, how to create this image, we create a file which is called a Docker file. It is just a, so we create a Docker file, and this process remains same. Does not matter if you are doing a small project, big project, everything remains same. You create a Docker file. This Docker file is nothing but this is set of instructions. I'll show you how does it look like. You create set of instructions. Okay, and then you Based on this Docker file, you create an image. So this Docker file, you can say this is, for example, if you go to any, now let's take that McDonald's example again. They have all their recipes listed somewhere, right? That, okay, if you're making a burger, for ingredient 1, you need to put this much thing only. For 2, you need to, so there is a set of rules which they follow, right? The set of rules is called Docker file. Okay. And once you execute those steps or you put them, that becomes your image. This becomes your image. Your application is still not running. What you have created so far, this part is called the creating the blueprint for your application. Okay, this part is called creating images, and you're basically creating a blueprint for your application. Once the image is created, then you can create, for example, suppose you have brought all the, like the McDonald's people, they have brought all the recipes, they have streamlined everything. They have people at different places who will do these tasks. Let's say everything is sorted. Now they can create as many burgers as they want. So same thing, now you can run as many applications. Suppose you just, right now I'm just running one application, but you can run as many applications as you want. Okay, these applications are nothing, they are called containers. Okay, so the first thing to understand in Docker is that the flow of anything in Docker is that you take your machine learning model, you take your data science model, you take your data engineering pipeline, anything. First of all, you write down a Docker file, that what is the flow of this particular project, and then you will convert it into images. So this is the step 1. Okay, and after that you will containerize it. So what is containerization? That, okay, my image is ready, now I will basically, I can run my application. So that's how it works. Now this image is something that you can share across here. This image, remember, it's a read only thing. It's a immutable thing. Once you have created an image, you cannot change the content inside an image. Okay, and you will share this image from here and there. So remember, instead of sharing codes with people, what you do, you share images, so that this application works perfectly. Because once your image is fixed, does not matter on which system you run, it will run properly. Okay, how does this work? What is this Docker file? I will explain you, but this is the logical architecture of Docker, and how does it flow. So tell me, if it is clear or not, if you have doubts.
So I have a doubt that C1, C2, C3 we are calling as containers are basically uh, this different systems we are running the same applications in. Is that
Yes,
correct?
we can run on different systems. Yes. For example, let's say I created this application, right? I've just closed it actually. This is my one container. I can create multiple applications, right? Like this is on my local host 8501. I can create same application on 8502, 8503, 8504, and so on.
Okay.
Is it clear, guys? Or
So
you have doubt?
basically, this image will run on different systems on a high level, is what
No,
the
image
thing
will
is.
not run on systems. I'll tell you. Image in itself is an entity. Okay, you will take this image to different system, and you will run containers on these images.
Ah, okay.
Okay, so in actual, these things run, containers run, not the
Okay.
image.
Swati, is it
Mm.
really like the cloning of the image that you're referring to?
Yes. So, no, this is not cloning. See, image is just a set of instructions. But once you have created an image, your application is not running. You just have, you think like this, you have a vehicle, right? So what you did, you purchased vehicle here, everything, you have vehicle stored in your house. Now, when you start your vehicle, then it becomes a container,
Okay.
right? So tell me, guys, is it, yeah, if you're in doubt, I'm free to discuss. We will deep dive more into Docker file, images, containers, but these are the only 3 terms which you will see. Docker file, you will see images, and you will see container. Okay. So if you, for example, if I just go to Docker website, see what they say. They talk about container, even in the, for example, let's say I show you Docker desktop. you'll see containers, right? You'll see images. So I have these images running. I will show you what they are. And these applications are running on this container. Okay. There are more things. We'll cover them in other session, but today we are studying containers and images. Okay. So yeah, please tell me if you guys what doubts you have. This is an open source. It is free of cost, available. Of course, it has some pricing as well, but like for running few applications you can do for free. But for a corporate level, if you need to use Docker, you need to buy some subscription as well. So that's how it works. Tell me, is the concept clear or it's going above your head? Okay. So we studied about images, right? So images basically are so there are two core building blocks, right? One is image, and one is container. So you can say that images are basically blueprints or template for containers that we have created. Okay, that you say that, okay, just compare this with a Python. Those who know Python, class and object, right? OOPS programming, that you create a class and based on that class you create different objects, right? So it is like that. Images, they do not run. What runs? The application will only run when your container is running, right? Image are just a blueprint, as I mentioned. Okay. The good thing about this images is that it does not matter on what system you are running, because everything you have put in here, environment variables, file, everything you have put inside this image and created a flow. And once you create a container, everything is present inside this container and it does not need anything from outside. Even if your system has some other Python version, it does not care, because it is utilizing the Python version of inside. Okay, now let's deep dive a little bit more on this images and containers and this Docker file. So let's see what a running container looks like. So let's say this is a container that you have created and your application is running, for example. Now remember what happened. What was the difference from virtual environment, which we mentioned? What was the problem with virtual environment? Tell me. I just told a few minutes back.
If we go to scale, then the availability becomes a problem.
The
Like
first problem is the different versions are there. If let's say on my system Python 3.13 is there and on some other version Python 3.12 is there, right? This virtual environment will not work. Yes or no? If 3.13 is not downloaded on someone else's system, this virtual environment will not work, even if I have created it right. Does it make sense?
So can we like a transfer like virtual environment we make on our own system, so we can make it on our like we can use it on someone else's system.
What we do, virtual environment is present, right? Let's say this is virtual environment. Agar mere system, if my system does not contain Python 3.12, will it run? It will not take it. If my
Yes,
system,
my
if,
question is something else. Like I understand this thing which you are saying, but I'm just asking you that I have made a virtual environment on my system. So is it transferable to someone else's?
yes, it is transferable. What is virtual environment? It's just a piece of folder. It's a folder only, right? For
Okay.
example, let's say I have this. This is my virtual environment, Docker. Okay. What is virtual environment? These are just some files only. Okay. So you can
Oh,
transfer those files.
okay.
Just a fancy name given environment, but these are just files. Okay. So the problem with virtual environment, as we discussed, is that they if the other system does not contain the version that I'm looking for, then it will not run. Okay. This problem is solved by containers or images or Docker. What it does, the first level it does is that Remember what happens first? First of all, I need a OS, right? Whether it is Mac OS, whether it is Windows, whether it is anything else. The second thing which I install in this container. So think like this is a blank container initially. So remember we spoke about four things. First thing was OS. What is second thing? Python. So I will install the Python version which is required for this particular application. So let's say the Python version required for this is 3.9, for example, right? I installed this. Then I will add my code which is present here. After my code, I will add my dependencies, let's say. And if there are some miscellaneous files, I will add them. Now, what I've done, I've created this. Now I will lock this. Okay. Now think like this. Does not matter if this container is running on my system or your system, right? It contains the setup. Remember, here we have actually downloaded OS. We have actually downloaded Python into this. But in virtual environment, we are not. In virtual environment, we are using of if that of that particular computer, of that particular system that you are using. But here you're using the virtual environment present in your container. This is the difference. So if I take this container, I run on my laptop, your laptop, someone else's laptop, it will still keep on running. Does not matter if my local system does not contain the right Python version or not. It's a, you can say this is a mini computer that you have created. Right, wrong, it's too complex. Guys, this is the like this you will see like everywhere. So I mean, if you're not understanding, let me know. I will explain more. We can go slow. We can cover complex part of Docker later, but just understanding why Dockerization is important. What is Docker? What is images? What is container? We need to know. Okay. So can someone tell me how Docker makes thing? There is a saying that Docker solves the problem of this works on my system but not some other system. How does Docker solve this problem? Now can you tell me, based on whatever we have discussed?
The problem that could be solved is like this will happen in a dev QA environment where the QA environment is different and the code which is built on is different. So if we run the code on say a staging or a QA environment and they say that no, it is not running on my system, but the developer says no, it is running on my system. So
Yes.
this conflict will not happen is what I think.
Yes, exactly. So what will happen, as you know, in any company, not let's forget about people. Let's in a single company only. There's a person who will create a model, right? He's a developer. Then there is a person who will test it, right? There are testers in the company. Then it will reach to some other company domain, right? And then it will reach to customers. Okay. Suppose developer created on some version, but it is not working on tester, right? That is also a problem. That okay, developer create. So how we are solving it? So what is the logic? How we are solving this problem? I mean, how Docker solve this problem, not we.
So what Docker is doing is it is acting as like it has an image of the OS, the Python version,
Yes.
and the code and dependencies and everything which is needed for that particular code to run in itself. So
Yes.
that's why it is standardizing basically
Yes.
throughout
Yes.
anywhere it can work.
Yes. So that's how Docker is working. And basically Docker creates mini computers. You can say like that, right? So any computer has Mac, has OS, it has Python, it has all the code. So it is putting everything there. Now, how this container is created? Remember, this is the finally container will be running like this. So as I mentioned, this container, first of all, you need to create a Docker file. Okay. Then which will contain your set of instructions. Based on this Docker file, you will create a Docker image. And based on that image, you will create your container. So let's try to see how this Docker file looks like. Okay. But tell me before that, is this flow clear to you? Docker file, then image, then container. Anyone who has any doubt on this? So let us see how does Docker file look like. Okay. So let's go to the VS Code. So what you do that after you have installed Docker, right? What you have to do, so this is your environment, like your coding environment. So you have an .env file, you have this, you have this. You'll create a new file and call it Docker file. Docker file. You don't need to give any extension. The moment you write Docker file, you will see an image of Docker here. It automatically means this is a Docker. Okay. So now let's discuss. Now I'm also just creating a readme.file just to discuss the steps. So what are the steps that we discussed? First of all, what we need OS, right? Second, what we need Python. Third, what we need?
Your code.
My code. Okay. Fourth, I need to install
Dependencies.
Dependencies.
And fifth, if there is any other miscellaneous work, right? I will see that. Agreed? So these steps I will write down in Docker file. Okay. Now here comes the another concept. Not, I mean, it's only a concept of base image. So what happens that every time you cannot go and download OS or Python from somewhere. Okay, it becomes a tedious task. That okay, every time suppose you have created this code, every time you create a code, you download an OS to your system, you download a Python to your system, it becomes a tedious job. To overcome this, manually you can do this. The step will look like this. To manually do this, you can use a concept of base image. Okay, we use a concept of base image before creating my image. So what I do that there are already pre-built images. Okay, there are some pre-built images which contain, for example, my application is a Python application, right? So if I try to find any Python image, so there are standard Python images present on Docker. So if you go to, there's a thing Docker Hub, just like GitHub. You all have seen GitHub, right? Similarly, there is Docker Hub. In Docker Hub, you will find all the images. Docker Hub. So Docker Hub container image library. It contains all the libraries. So for example, let us say you have a library of Python, Java, whatever you want to see, you can go there. So simply I will do one thing. I'll say Python. Let's say search Python here. Okay. So this is the Docker official image of Python. So it is not created by any random person. This is the official image that you can use. So technically, what are we going to do? That the first two parts we are not going to write on our own. We are going to import from somewhere. Just like in libraries, we import something from somewhere else, right? Similarly, we will import these two from somewhere else. And this is stored in the pre-built image which is present in. Let me show you how does this look like. So for example, when you click on this is the code which runs in backend. If you don't directly use this, you will have to write down this big whole code. Okay. So to avoid this, what we do, we simply use a Python base image. If you are doing a, let's say, Node.js, suppose you're creating a node, this Node.js is also an application, right? If you are using a node application, you will go and see Node.js is a JavaScript based platform. So you can simply use this particular image, which is present from the website. Okay. Is it clear, guys? Is the concept of base image clear to you? Why do we need a base image? Why do we need a base image?
To avoid the tedious tasks
To
for
avoid
downloading
tedious
the
tasks,
Python
right?
application.
Otherwise, we will have to run all this big code. I don't want, because if something is already built, I will just use it, right? Why will I I will have to understand what does this code mean and all that. I don't need to do that. So simply use this. So what we do in the Docker file, we go the first step in your Docker file is if you want to import from any base image, right? So right now we are importing Python from a base image, which will contain OS and it will contain Python. So I will write down from base image, right? So what is my base image? So for this particular scenario, I'm using Python, which is my base image, and Python will have different versions. Okay, so I'm using, let's say, Python 3.9, and it is called Python 3.9 Slim. Okay, this is just a name version which you will see on Docker website. You don't need to worry about. The main thing you need to know is that what does this statement do? For example, you are not coders. For example, let's say if you're not coders, what does this step do? It eliminates the first two steps which we had here, OS and Python. Okay, now in your library or the Docker image that you're going to create, uh, the Python and OS will, this part we have done. Okay, so this part, the first two part we have done. OS we did and Python we did. So OS part is done and Python part is done. Is it clear? So let me do this in an Excel because I have to explain one more concept parallelly. So insert shape. Okay, so this is my, for example, this is my, let's assume this is my system right now, which I'm working upon. Okay, so this is my system. And I am creating a Docker image, right? Or you can say I'm creating a Docker image, then a Docker container, whatever I will say. Let's say I'm creating a Docker container right now. For that container, I need to create instructions for my image. So what all have I done till now in while creating my image? I did my OS, I did my Python. Is it correct? Now let's think about the next steps. The next step will be, where is my VS Code? Okay. Now, if you notice this thing, this particular, I'm working in a folder Docker here, right? This can have subfolders, this can have so there are a lot of files present in this folder. Now, think like the container is also computer only, right? You're moving your files to a container here, which we discussed. So containers need to have you need to provide a location, because for example, let's say in this container image, there will be different folders. Let's say there is a folder 1, there's a folder 2, there's a folder 3. You can create multiple folders inside a computer, right? So let's say I want to move all these applications inside a single folder, and let's call it the name of my app. Let's call it my app. Okay, so right now in my system, things are present in a folder called Docker, and I'm putting all those files inside which are present in this folder to a folder called as my app. So what I need to do, I need to set up a working directory that where I'm moving things inside my Docker container. So this is called a working directory in the Docker. So we are saying that, okay, now what I will do, I'll set up a working directory. Set the working directory. So how to set up work directory is simple. You have to use a keyword work dir. Okay, those, I mean, for me, this GitHub Copilot is working but you can use without that as well. And how to use work dir, that you have to go inside your Docker container. Inside that there will be a folder. Let's create the folder name as let's create a chatbot. I'll name it chatbot. Okay, so what will happen with this? Can someone tell me? I have created a folder called as chatbot inside my Docker. Is it clear? Guys, yes or no?
Can you explain this again? Like, what are we doing exactly?
Tell me, you have codes present in your system, right? You need to put things in a Docker. Agreed? So there needs to be you need to transfer something from your system to the Docker container. Agreed or not? The code is present right now. It's present in my system. In the Docker image or container, it's empty right now. So I need to move the files from my system to Docker container. Is this concept clear? This much clear?
Yes.
Now, what I told, Docker image or container, they are also computers. So there will be proper folder structure. Just like in my system, there is a proper folder structure, right? For example, if you come to my desktop, I have these 4 folders. I have placed that thing in a particular folder only. Just like this, in the Docker, you want to put things in a particular folder because you can put multiple applications there, right? In a particular Docker. So what you can do, you'll create a folder for this application. Is this conceptually clear what we are doing?
So we are making a folder for all our files to be kept, like what we are trying to transfer.
Yes.
So
So
we
we will transfer files from my system to a folder called chatbot in the Docker container.
okay.
Guys,
So
yeah.
it's the image, it's the same, na image or container. Like it will
Image
go
and
the
container are different. We are first create this right now. We are creating a Docker file, right? This Docker file will create an image, and that image will create a container. But these things, whatever we are writing, will eventually go in your container only in this way only. So this is just the blueprint. Remember, image is just the blueprint, right?
Yes. Okay.
So right now we're just writing down a blueprint. Okay. So guys, is this much clear? What is work directory doing? We are setting up a work directory in my Docker container. Now, what I need to do next? Let's go 2 steps. I need to move. So there are a lot of files in my system. If you see, I need to move all the files from my system to Docker. Agreed? So what will I do? I will copy. I'll copy or cut. Tell me. Will I copy or cut?
Copy.
Copy कर लेते ना, cut क्यों करना है? Right? So I will do. I will copy the current directory towards the app. So how it is done? This is my chatbot, right? Now, whenever we copy, what do we need to do? We need to know a source location and what else do we know? We need to know
Destination.
destination, right? दो चीजें चाहिए. What is my source? If you see, my source is my present folder. How to write things in Python is that you can simply suppose I am creating a Docker file inside this Docker folder, right? All the files are present inside this Docker folder. Means this is called a root directory. That all the files present inside this Docker folder, I can name them simply dot. But dot means everything which is present inside the Docker folder, which it will go through it. Apart from Docker file, of course. Okay. And what is my destination? Destination, I created chatbot. So what I will do, I will use a copy command, which will do copy everything from my every file. So let me write it down here. I will use copy, okay, source destination. If you see, there is a source, there's a destination. Okay. So what is my source? Source is dot. Dot, what does dot mean? All the files which are present in this Docker folder. Okay. And then where are they going? They are going to the chatbot folder in the Docker container. Clear, guys? Any doubt, anyone? We'll just do this Docker file today. We'll run an image and run a container on it. That's it. Remaining part we will do in next session. Okay. So tell me, is this part clear, that we are setting up our base image, we are doing a setting up work directory in my Docker, and then I'm copying things from my system to Docker. This is my system. The first part is my system, second part is my Docker. Once I have moved, what was my next step? So this part I've done. When I copy this, means I have copied my code as well, right? What is my next step?
Install dependencies.
Install dependencies. How do you install dependencies in your currently? How do you install it? We do pip install r requirements .txt. Correct? We do this part only. Agreed? So same command we are going to write down here. But so what will happen? Once we have copied everything, remember, once we have copied everything, what do we want to run inside Docker? We want to run this command, right? Just things are exactly same, just like you do in VS Code, right? So what you do, you will come to Docker file, you'll write down a run command. So you will say run, okay? Then you'll say pip install r requirements.txt. So once you run this, what will happen? All the dependencies which we have created, it will install in your Docker container. Okay. So with this, I installed Python and OS. With this, I set up my folder, I copied my files, and now I have installed the dependencies. Okay. Is it clear, guys?
Files both are the same, no?
Sorry?
Virtual environment, whichever you have created, .env file and requirement.txt, both are the same, because environment is also containing the same files and requirement.txt also containing the same file.
I didn't get your point.
.env file which you have created,
Yes.
it has same dependencies, but those are in your system, and we are installing the requirement.txt.
.env has no dependency. .env is just API keys.
Okay. Sorry.
.env is just your API keys. Okay.
Okay.
So, okay. Now tell me, once after you install, okay, now tell me how we do things in VS Code. We put our code, we do pip install. After pip install, what do we do?
We import.
Enter.
No, sorry.
नहीं, import तो सब लिख दिया ना, कोड तो हो गया मेरा, पूरा चला गया. अब बस मुझे कोड रन करना है, right?
Yes.
Let's say I've installed everything. What next do I do? I simply run the code. If I have everything there, if I simply run this, it will create an application for me, right? So what should be my next step in the Docker file?
Running the code.
Running the code.
Run
So
app.py file.
yeah, so
Run.py.
running.py file. So for this we use a command prompt. We use thing called cmd command. Okay, remember we can run things from here as well. We can write down Python app.py. Have you ever tried this? This also works, right, in your command prompt. So same thing we are going to do. What do we need to tell? We need to tell two things. First of all, what type of file are we going to run eventually? And second, what is the file name? Okay. So the format for this is we use a list. We say cmd. Okay. After this, we use a list. In the list, the first variable needs to be which. Let's say if I'm using Python, I will use Python. If I'm using Java, I will mention Java. After Python, I need to mention the file name. So what is my file name? app.py. So what it will understand, okay, I have to run a file application, which is a Python file. Okay, it is explicitly you have to provide this. So let's go to Docker file. I will now run it. I will say cmd, okay, Python app.py. This is the Docker file. That's it. Okay, this will help you create image. Now tell me, are these 5 steps clear to you guys or not? This This remains same. See, there is nothing of Python here. These are just standard syntaxes you need to know. Iska kuch Python, Java se rehne dena nahi hai. These are just command prompts, which I have just taught you. Okay. But the flow, did you understand the flow? If you just see a Docker file, you will, let me show you another Docker file, which is present online. We were discussing about this one, right? This one. If you see, this contains from, forget about env right now. Then what do? We are setting up some environment, and then we are running a command. We're saying, okay, run the Python file. Okay, run this file, run Python file. Exactly same we are doing here only. We have added few more things. We said, okay, first download the Python, create a folder in the Docker container or image, then copy all the files from my folder to Docker, then pip install, and then run the application. Clear, guys? Tell me if you have any doubts. Just few more minutes, like 10-15 minutes more I need. Then we can stop the session.
Work directory itself, a folder in that chatbot is another folder lying in that.
With this one,
Yeah.
work directory is just an indication that you're setting this as your work directory. So whatever code you're going to run from now, it will run inside this work directory. So we are just saying that, just like we do here, we write cd commands, right? We say cd desktop and all that. So we say that we are in this folder and we are running everything in this folder. So it means exactly same.
Okay.
So so let's move on. Now there is one problem with this. Before I run anything, can someone tell me what is the problem? I mean, code is correct. This is not, I mean, this part is correct. There's one problem. If you see, I have a .env file. If I told you, what did I tell you about images? You will create Docker images and you will pass on to pass on here and there. Like you will upload to, like people have uploaded images here, people have uploaded things here and there. Now these .env file contain your passwords, your API keys, right? Do you want to share them with anyone?
No, we will create environment variable in while
Yeah. So
deploying it.
first of all, what we need to do is we need to stop something that while I am copying these files, right? That so right now I'm doing copying everything from my current directory to a folder called chatbot. First of all, I need to stop this. I don't want to copy .env file. Agreed? Yes or no?
Yes.
Yes.
So how do we do that? So to do that, we use a file. You would have seen we use a Docker ignore file. We write down .docker ignore. Okay. So you will see the moment you write, it will also create a Docker container. So all you need to do, you just need to mention the file names which you don't want to transfer. Okay. So for example, I don't want to transfer .env file. So what will I do? I'll say .env. I don't want to transfer this file. Also, suppose this readme, this is my personal file, I don't want to share. I'll say don't transfer readme.md as well. So what is it going to do? That in this step, when it is copying everything, it will not copy these two files which are present. Okay. So technically what all will go? This Docker will go, this app will go, this requirement file will go. Eventually, this readme will not, because this is for my personal use case, right? It will create extra space. I don't want that. env I don't want to share because this is my API key. Clear?
Yeah, similar to git ignore file.
Similar to, yeah, like you have git, just like git ignore, there is Docker ignore, right? And git ignore also we do this. Those who know about it. So now my things, my this is my Docker file. It is completed. Okay, any doubt, anyone?
No.
If some,
All
I'm giving
yes.
1 minute, please think and let me know if someone has any doubt. Just 5 more minutes, 5-10 minutes more are remaining. I'll just show you how to create this. Then we will, in the next class, we will study what all things are there, like how can we optimize this, what more things can we add or subtract, right? So no doubt, anyone? Are we good? Okay. So now we have created Docker file. What is my next step?
Creating image.
Image.
We have to create a image. So there are commands for that. So we will write down throughout this course, we will write down the commands which we required, right? So first step, we did the step one. Step one was to create Docker file. We did that, right? Docker file. Now step two is to create. Step two is create image. Okay. Now how to create an image? Basically, we use a command. So there is no science. Like this is just a command thing, right? So what you do, we use a command called docker build. Okay, and we give it a tag. So T means tag. Okay, where we can give my image a name. For example, I name it chatbot. Okay, I'll explain what does it do. So if from my Docker file I want to write down, I will say docker build. Build means we are building an image. Okay, after that, for every image there can be name, there cannot be name. If you don't give any name, it will come like this. If you see, there are two images here. Can you see this? These are the two images. One image has a name, one image does not has a name, right? So if you don't give any name, it will just create an image ID. You can identify your image based on image ID, and you don't need names and tags. Okay, so this is optional part. I'm just doing that to show you, but we will explore them more in next class. But let's, so what do? We do docker build. T means tag. Okay, so understand, T means tag, and after this I need to give my name. So let's call it chatbot. Okay, now this docker file, so from where I am building this, from which directory am I building this? I'm building through my current directory. How to get access to my current directory? We use dot. Okay, so I will use a dot here. That's it. Now see what is going to happen after this. So I'll just put a command here. This is readme.md. Sorry. So this is the first command, create image. We'll go through a lot of commands in this course, which you don't need to know everything. You can search online as well, but these are the basic command. How to create an image you should know. Docker build and then chatbot. So now come to Docker file. Now I will run it. So everything will go from start. See what is happening. First of all, it will load definition. Okay, it is load. Now let's read. Load metadata from Docker file. Okay, it is loading everything from the base image that we created. After that, it copied everything. 2 done, 3 done. After that, it is now running pip install this requirement file. All the requirement file which I generally do, they are going in my image. Okay, so this is their building image. It will build and exporting to image, and you will see image. It will just get created in a couple of more seconds, most likely. Unpacking chatbot latest. Now see, this my image is created. So see what all steps were there. Let's see. First of all, it loaded the definition file from the Docker file, right, which we created. Transferring Docker file, first of all, it will transfer, then it will load everything from python.slim. This is the base image that I created. It will download everything from there. Okay. Once it has done that, so remember this part is taking care of that part. After that, it created a work directory in my image or container that we are going to create. And then it is going to copy all the folders from my system to the chatbot folder. Then it will install everything, right? And the image is created. Now let's see how does this image look like. Now, if I go to my Docker, you will see this chatbot image is created. It created one minute ago. Right now, it is not showing green because there is no we have not created any container. This is still unused, right? So that's why these containers are already running. So that's why it is showing. But this image right now, this is just an image. So if you see, what is the size of this image? 1.62 GB. From where does this data came in? मेरा जो code है, ये तो कितना ही size का होगा, for example. What is the size of this code? Hardly KBs, right?
KBs, yeah.
How does the size of my Docker image become so large?
Because it has the OS image kind of it
Yes,
has created.
it
That's
downloaded
why.
OS, it downloaded Python, it downloaded all other dependencies in my container, right?
It has all the libraries have been installed, and the
Yes, every library that we mentioned, right? Everything got installed there, right? So all those things take. Remember, Windows OS, they are heavy, right? So they take space. So that's why images are heavy generally, if you see. And so this is my image name, this is the version, this is the latest version, and this is my image ID, and this was created 2 minutes ago. This is the size and which is created. Okay, so now my images, yeah.
Yes, sir. So here we see that there is name, tag, image ID, and all the other details. So
Yes.
what should we have to keep in mind while identifying any of the
Image ID, image ID, image ID,
So
or you can use name as well, but image ID is is the best thing. If you don't remember image ID, you can use name followed by a tag.
Okay, sure.
I will show you that part. I'll cover in next class, that how do you identify, explore things. Right now, in this class, I'm just exploring how you create these Docker files. Okay. All clear, guys? Anyone, any doubt?
What is that play button besides that, or that is also later to be explored? The play button besides the image, the size. Yeah. Yeah.
This is running image, so it will
Right.
create a container. We will run container through code. Okay. So I don't want to run container through here. This is just a UI, right? So they have given option, but you can run through here as well. Okay. So we have created an image. Is it clear, guys? Anyone, any doubt? Now, what is my next part? I created a Docker image. I created a Docker file. I created a Docker image. What should be my next part?
Containers.
Container.
Now, my last part is what I'm going to do is create. Step 3 is create container. Okay. So containers are created from images. Is it right? So the
Yes.
command that is used is Docker. So we will use a lot of command, but today we are going to use Docker run. Okay. It means I'm creating a container on this image. Okay. This we are using IT. IT means interactive. I will explain its definition in more detail in next class. Interactive means that there are two type of container. One is attached, one is detached container. So that all we will cover in next class. But for now, understand IT means you can basically the whatever output of your application, you can see that in terminal. Okay, so that means IT interactive. You can put your input, you can just write down input there, and you can see the output. You can control things through terminal. That's why we use interactive. Okay, so what do I need to mention? First of all, remember this: the application that we are going to run, it will come on a web server, on a website. For example, it was running on my local host. It was coming somewhere, right? Every computer that we use, it has a port. It has like a they are ports. So ports, they are numbered from I think 6-digit numbers. You can vary it. What are those ports? What they do is just think like this is your system, right? You can run multiple applications on this. So suppose this has multiple ports for your websites. Okay, suppose on this your website 1 is running, on this website 2 is running. Generally there are few predefined ports. For example, let's say you run Postgres, it runs on a certain number of port only. You can change. So port are just optional things that, okay, I created my application, now user will be able to access through this particular port. Okay, इसका मतलब ये है कि वेबसाइट में जब मैं उसको डालूंगा, so it will give me that particular application. Okay, so you have to specify a particular port number when you are running a container. So let's go here. So how to specify a port number? You will mention after IT, you will mention P. P stand means we're providing a port mapping. Okay. Now there are two ports. I will explain in detail in next class. One port is of your Docker container and one port is of your system. Okay. So what is happening right now? Now understand this concept. Your Docker will also have some ports and your system also has some ports. Okay. Now you as a user, are you accessing website from system or you are accessing from container? जैसे तो गूगल क्रोम जो मैंने रन किया वो मैंने सिस्टम में रन किया है और आई हैव रन इट माय कंटेनर
on your system.
Yeah, so I'm accessing the output of this model on my system. So what will happen? Docker also has a port and I also have a port. I need to map them. Okay, that whatever Docker runs, it comes through this port and I will take that in my system port, right? So there will be two ports which are connected. One will be Docker containers port, one will be my systems port. So how do you connect them? First of all, you write down your system port. So let's say I want to publish this application on let's say I want to publish it on 8001. It can be any number. So they are generally, these numbers can vary from 1 to 6 digit, right? You can vary it. And let's say what is my port of my container. So in the code I have mentioned it is 8501. Okay, it is mentioned in the code in this app.py. So what is happening from container, it is taking 8501 port and it is pushing it to 8001 on my system. So whenever I'm going to run my system, I will use localhost 8001. Right now nothing is coming, correct? Because there is no connection. I have not created the container yet. So right now my application is not coming. So I will come once I run the container part, then it will run. So now see what is going to happen. So Docker run IT means interactive, P means port. I have given the port. Now one more thing. One last thing that you need to mention is this .env file contained Grok API key, right? This AI application cannot run without an AI because you're using some LLM models here. LLM models require an API key. So you do need to pass this environment file. Okay, so we have not pushed this environment file in a image, but whenever a user runs, user will pass his own API key so that he can launch his own application, right? So what we are going to do, we are going to write down one single line that it will say env means environment, okay, and then file which is .env. It means I'm using this image with an .env file variable name. Okay, and after this I just need to pass the image ID which I had here. What was my image ID? Or I can use an image name as well. So this was my image ID, AC14, something like that. I will copy this and I will go to my command. So this is the command which I'm going to run. Sorry, I did it. Docker image. But this was the last part. I will just run and show you how does output come. Then you guys are free to. So this is the image that is created. Okay, now I'm going to run this command. Anyone has any doubt on this command, please ask me before I run. Docker run. Yeah.
So here after that .env, so we have taken just some 10 to 12 digits, no, of that key.
Of this is not key. This is image ID.
Image ID. Okay, sure.
Which is
So
present
we
on the
have to
Docker.
take the image ID
This
after
is a
that
Docker image
.env.
ID. This is not the key variable. Key will go through .env file, right? I have mentioned this .env file. So what will happen whenever you run application, it will put .env file, the variable grok API key, it will pass the whole value to that code, which is required. Okay. So now this is readme.emd. Now just let's run it. Let's see what comes. So see, my container is running now. Before I show you anything, let's see if my container shows running or not. Now, if you see, there is a green signal here that this image has a container running. Let's go and check container. Yes, this container is just created 16 seconds ago. I have not given it a name. If you don't provide it a name, it automatically gives it a name. So this is a container which I just created. It is running on this port 8001. If I click it, it will take me there, but I will just go there. So this is just an indicator to show that your container is running. And now let's go to the port. Let's see. Now my application is running on this port. Now I can ask it anything. Let's say, what is capital of France, for example. See, this is running. Now this system, I can just convert this link to a dynamic URL and I can pass to anyone. And as long as I'm running this container on my system, as long my system is open, this application will keep on running. Okay. The moment I close my laptop, it will close. For that, what do? We deploy this whole container on a cloud server so that it runs 24/7. But this is the concept of Docker that we just discussed, the basics of Docker. What is a Docker? What is a Docker file? What is a Docker image? What is a Docker container? We will deep dive more in next class, not right now. But yeah, so that's it for today's session. If you guys have doubt, please let me know. We can have a doubt session.
Hello.
Yes.
Yes, so yeah, currently
Your voice is not clear.
we have checked that all the Docker and content.
Your voice is breaking.
Hello.
You're not audible. I cannot hear you.
Yes, currently I am saying that. So is there any prerequisite for this Docker content which we have learned today?
No, there's no prerequisite. Did I teach you any code? I didn't teach you any code. These are just commands that you need to run.
No, I'm saying that for just practicing also. So what a prerequisite, a basic prerequisite we must know, or means if we prepare, then it will be okay for us.
See, I told you don't have to. I mean, if you know Python, you can create machine learning model. That is good. But for Docker, you don't need to have any prerequisite. I didn't teach any technical thing today, right? We just discussed conceptual things.
Okay, sure.
If you know Python, you can create this code. I'm not going into that, right? But learning Docker has nothing to do with learning Python. They're separate things. This is just a concept which you use in your day-to-day work, and that's how you basically run it. Yep.
Hello.
Yes, please.
Yes, so here we have taken the two API keys, no, in that grok
Yes.
env file.
Yes.
So there's that API keys
Sir, your voice is breaking.
are means valid for unlimited time. Or,
these are valid for unlimited.
From that grok.
Unlimited. This is valid for unlimited time. You can.
Okay, so
you can reverse
there is API keys.
Yeah, please.
Yes, I was saying that we can means multiple user can use this API keys at a time.
Multiple people can use it at a time. Yes.
Okay.
But API costs money, right? The Grok API is free. It does not cost money. But if it's other API, it costs money. So people don't let you use their money, right? For companies, when they launch a website, company use API. So whatever users use the website, company has to pay that money, right? So that's how it works.
Okay, and for Postman and Selenium, they provide free IP or these are paid.
API is paid always. Postman is used to test your APIs. Postman does not give you an API.
Okay, sure.
They used to check if your API is working or not. The Postman is that part. Okay, guys. Yeah. So yeah, please.
Yeah, so I have a doubt that if our code has some errors and we have deployed it to Docker, like
Yes.
image from the image, so is it an easy way to delete that image, or should we be very careful while like
No,
coding?
you can delete images. There's a very easy way.
Okay, okay.
So I will discuss. That is called Docker rebuild. We use a rebuild command for that, or we use
Okay.
Docker rebuilding concept for that. But
Just
that's
one more thing, like the last command which we have created the container. So
yeah.
here we are doing two things, like we are naming the ports, and then we are doing that env thing as well. So this command is doing two things, right?
This command is doing two things. Whenever you run your, remember when you run any GenAI application, you need to pass a .env file, right? We used a docker ignore where we said that okay, .env file will not go. So in the image, I don't have a .env value actually, right? And without Grok API key, my chatbot will not run,
Yes.
right? So that's why we need to provide the API key here through .env file.
So is it, so we are basically passing the same file which we had ignored?
Yes, yes. No, so
Yeah.
there's two separate things. We created the file in image, okay? Sorry, we removed the file while creating image, because image we share with here and there, right? Image I can share with you, you can share with someone else, right? So in image my key should not go. But when I build a container, I'm running an application on my website, right? It's on my website. So people are using website, not even, I mean, think like this. Let's say I'm a company, I have launched a website. Customers will come to my website, right? They will use, and I need to pay for their usage. That's how it works, right?
Yeah. So when we're making one container, we of course need to like give the API key, because we are trying to run that thing that
Yes.
right away.
For
Yeah.
example, I launched a website, right? Uh, this is the website. In this website, in the backend, there are my username, my password, anything. While using this website, can you see my ID, my password? You cannot see them, right? But every time you run a query, it costs me money, because in the backend that API is getting used. Okay, so
Hmm.
you will not, as a user, you will not be able to see my API. But if you use my product, of course I have to pay, right?
Hello.
Yes.
Hello. Yes, I was saying that means you have taken the example of this, no, your website, datascienceai.com.
Yeah.
Yes, so I was saying that means you just open the link of that practice.datascience.ai.com. So
Yes.
by putting this complete website, including the practice in on the first side, so if it opens and if it remove the practice from the first side, then it doesn't load it properly.
It does not.
Load it means it is not opening it.
That
It is
website is
showing
not
that
launched.
this
No,
page.
I have just launched one part of my website. I have not launched the complete website. So that's why it's not
Okay,
coming.
sure. So means it is your website only, no? Both the
Yes.
means practice and this one.
Yes.
Okay, sure.
Yeah. Anyone? Any other doubt?
So I have a doubt which is unrelated to this session. It's just like when you were typing on your system, it was automatically indicating to you like what
That
needs.
is GitHub Copilot. You need to, while you install VS Code, you
Yeah.
can set up GitHub Copilot. So it helps you in writing down,
So
like
is
auto correcting codes. It helps sometime. Yeah.
okay. Is it like free?
Yeah, it's free of cost. I'm not using paying any money for that.
Okay, okay.
Thank you.
So it completes your code. So if you see GitHub, uh, uh, when you log into VS Code, right, you will see there is a option of GitHub Copilot. You can activate it and you can access it. Just download the latest version. You can access from there. Yes, please. Someone has asked a question. So if you guys are all good, let's close the session, right? Yeah, please.
While deploying on the any cloud services,
Yeah, right.
that
Right
time
now, I have just deployed on my system, not cloud. Cloud I will do in
yeah,
coming.
no, I'm asking about that. If we give these grok file and all API keys in environment variable, then
Yeah,
it is good, or that practice is good, or this practice is good while creating containers.
you have to give API keys in containers, not images. You can do that in images. I'm not stopping you from that. But the thing is
No,
that
no, no, no. I'm not asking about that. It is good practice to give environment variables in sorry, these API keys at the time of building containers or while deploying on the cloud services. That there we get one option like
at the time
you
then you
can.
can do on cloud services. Then you do on cloud. If you're using cloud services, then you put those API keys on cloud services. Then they will handle it more better.
Okay, means we put like in for example,
In
like there is
AWS,
option
right?
environment
There is a
variable.
AWS secret key option, right? You can
Yeah,
go and in GCP also there's GCP secret key. So you can
yeah.
provide these API keys there.
Okay, okay.
So guys, anyone any doubt? This is just the basics of Docker. Like we haven't gone uh where any Docker container or desktop version do I use? Yes, I'm using my system CPU right now because it is
Hello.
running on my system. So it is using my system CPU.
Hello.
Yes, please.
Yes, I was saying that if we have to learn on that Azure,
Yes.
so we have to purchase or subscribe for that using the mail ID. If we means continuously daily practice or daily learn on that Azure portal, then
Okay. So I
so
didn't get it.
means no means if we I have to practice some code on daily basis or on alternative basis and multiple times in a month, then I have to subscribe that using that mail ID for Azure or means how it works.
You have to subscribe to take the sub, so you get some credits as your credits, right? And once those credits are used, then you need to pay for how much, like whatever based on your usage you need to pay. That's how it
Okay,
works.
so what is that predefined and that default uh, subscription or
That you can
some
check in
hours will be there?
AWS. Even I forgot, right? I haven't used AWS for long. You can check on the website. Even I don't remember, to be honest. uh, you can check. I mean,
Learning on
they
AWS is free. Learning on AWS is free.
okay,
Yeah,
learning is free.
right.
I think it's paid on then on some other cloud. So
Yeah.
I think deploying your projects cost money. Just writing down, running some queries and all that, they will be free. Yes.
If you create a new ID on AWS, yeah,
Yeah.
it is free for 1 year.
Okay. Okay. Yeah. So that answers right. So I have pasted all the commands in the GitHub repo that I posted. Right. You can use. So this is a Docker file that I created. This is the README file that I created. Just to check it, and let me check if I missed anything. Requirement is there. Yeah, I think Docker ignore you can also create. So let's say I do Docker ignore. Docker ignore. Okay. Yeah. So this is the code which is present. I have shared code in the main section. So I'm just sharing once again. this is it. It will be present in the YouTube live video as well. The video description you can access from there. Okay, thank you guys. Thanks for joining. You can use this link. I'll put it in group as well. So thanks again for joining the session. I hope it was some helpful. I'll give some practical assignment. Make sure you guys are able to solve.
Yeah, sure. Thank you for sharing your knowledge with us.
No problem. Yep. So thank you guys. See you in the next class. Okay.